Hi guys, how you doing? I'm Will, engineer at Fat Lama. This is Larry, he's our mascot, Fat Lama, and we're going to talk about sort of planning and migrating to an agile architecture. So I know a lot of people might be already in sort of enterprise companies where you have a lot of existing systems, not necessarily building greenfield, so I want to talk about some strategies for migrating as well. Okay, cool. So just quickly, Fat Lama, yeah, we're an insurance-backed marketplace for lending and borrowing anything. Have 100,000 users in London and growing very quickly. We just raised a Series A round of funding. We have some great investors. We started with Y Combinator, and recent round was led by Blossom Capital, Tomico. Importantly, we're hiring, everything on engineering, front end, back end, data, mobile, absolutely everything, data science, design, growth, product, operations. We're growing extremely quickly as a company, and we'd love to hear from you. Basically, if you could come and talk to us, careers.fatlama.com or email me, just will@fatlama.com. So, as was mentioned, a couple of places I've worked, don't want to dwell on it, but the reason I wanted to show this is I've worked at tiny startups, I've worked at big enterprise companies, and I've seen companies grow from one into the other. So some different things along the way that help form these ideas. So, okay, you're here probably because you're either moving to or already in an agile team, and this might be what you are currently working with, more of a legacy setup, and you have like these different functions that all work on their own sort of pieces of the system. So maybe you have a front end and back end team working on some monolith, and only an operations team that touch the infrastructure. And this seems to work, right? But you want to become more agile as a company, as a development team. And so you might, you hear a lot of people here today talking about having cross-functional teams. So that might look like this for us at Fat Lama, something we're going through. So we might have a borrowers team, a lenders team, business operations, engineering, forward, whatever it is. As soon as we have these cross-functional teams, now every team has to touch every different part of the architecture. And I've made this intentionally messy to make a point, but I think it is true. You have everyone needs to touch everything. And when you do that, you might encounter some problems. So what I wanted to talk about is how to solve some of those problems. So some of the problems are quite simple, right? You just have too many cooks. You have large and risky deployments, as everything is in one system, everything in that monolith, into the situation where there's a huge amount of change every time you want to deploy, and maybe you're on a deploy cadence that's every week or month, or maybe you go even faster and more agile and multiple times a day. We're deploying multiple times a day, and we still get to the point where we have risky deployments when even 10 people are making changes on the same code base. Importantly, you can be deploying code that you don't even understand. Maybe I'm making a change as part of the lenders team on this product, and someone else from the borrowers team is making a change as well on the same thing. I didn't even realize, I'm not part of their process and what their team's building, and suddenly I'm deploying this piece of the code that I have no idea what it's doing. Maybe they're going to break something, and I'm not going to understand what's happened, how I'm going to fix it. And the simple stuff, you just have everything in one system. You're going to have long-running test cycles. You might even have contention on files and lots of painful rebasing and that kind of stuff. But I think more importantly, you end up with a lack of ownership. And this is one of the things that Luca talks about, and I'm sure lots of other people will on the vision stage as well. Like, if you have this lack of ownership, you have all sorts of problems. So multiple redundant patterns for the same thing. We even see this at Fat Lama with 10 engineers. A slow process to reach consensus when you do have multiple patterns. So maybe you want to change the way like your API responses are structured or something, and it takes a long time just to get everyone to agree when everyone's in disparate teams how one thing should be done. And something that I definitely saw at Uber was the fractured relations between teams, and this is probably something that people don't necessarily realize is happening, but before you know it, like, you get this animosity between teams where another team might change something, and you don't know about it. We had this instance where we were shipping the first version of Uber for Business back in 2014. We were going live, I think, at 9 a.m. on Bloomberg with our VP, whatever, of business announcing this product. And at, I think, 1 a.m. the night before, another team made some changes and completely broke the system. We were up till like 7 in the morning, like trying to fix this and deploy to get it working. We did, but coming out of that, looking back at that other team, we thought, this was very, very painful for us, and they didn't even realize that it had happened. So you do get this when everyone's working on the same thing. You just like really strain relationships between teams. So I think that, and this was sort of alluded to before, but the most overlooked scaling problem isn't necessarily about requests per second. It's about developer experience as well, and how everyone's working together. And this is like the biggest problem that we face as an engineering team at Fat Lama. It's not necessarily like pure scale in terms of queries, but just how we work effectively. So a more modern architecture, this is very vague, but might look something like this. Each of the teams has like their independent areas of the system, might be broken down with strong ownership. Obviously, these different systems are going to have to communicate, but they're owned and they're smaller, and they can all be sort of deployed independently. So, that leads itself to microservices and that kind of stuff, which we'll talk about a little bit. But I want to talk about rules, my rules at least, for modernizing, going from the legacy system to something a little bit more like I just showed. And the first one that I think people don't always sort of realize is that you have to deliver business value along the way. This may as well be called like beware the fork. I think that any time that you have to like fork your code base or your part of your business, you're at a huge risk. Right? And I've seen this happen plenty of times. Like the number of times I've seen forks fail it's ridiculous. If you don't know what I mean by fork, I should say that's just like stopping development on one thing, saying we're going to rebuild everything completely, and trying to build that from the ground up, and then just switching everything over in one go. So delivering business value along the way is extremely important. Respect what came before you. I think this is something that's quite important to me. I think there's so many instances where you think, okay, we're going to rebuild this system. Sure, how hard can it be? Just look at it. It's only a simple page with these few functionality. Like we'll rebuild that in a month. Like no problem. And then you get into the weeds and you realize actually there's all these intricacies and all these other little edge cases that you didn't realize. And it turns out the old system is a mess because it was hard, and it was like something that people had to deal with at the time. Maybe there's different business pressures, whatever it was. But if you don't give it that respect and learn from those things, then rebuilding everything is going to be an absolute nightmare. Choose what you know, not what you want to know. This is a classic problem for engineering. We all want to work on new, interesting technologies, and when you're going to like modernize your system, you want to pick like the latest stuff, which is great. And sometimes you do have to keep learning. But if you're going to rebuild a critical part of the system or something like very important to the business, and you go and choose like a completely new technology that none of your team are familiar with, or maybe even it's emerging in the space, you're going to run into so many more problems than if you just pick something that you actually already know. We see this all the time, even with like interviewing people. They choose to use a programming language that we use, not one that they know, to do the interview, and it always ends in a disaster. Don't build when you can buy. This is pretty simple. It doesn't necessarily mean buy, but also use open source things as well. There's plenty of software out there to make these kind of migrations much simpler. Don't try and build everything yourself. And also, similarly to the choosing the new technologies, beware technology hype. Maybe I'll talk about this a little bit more. So this is a graph from Gartner that shows like the technology hype cycle, they call it. There's like an innovation trigger starts off this new push for a new technology. Everyone thinks it's the best thing in the world and it's going to solve all your problems. They start implementing it, they realize actually this is a nightmare and it's not productive at all. And then slowly the technology develops and you get to a point where you can actually be productive with it. The good news is for some of the stuff that we want to use, we're already climbing that slope. So I think that like Docker right at the top here is in a plateau of productivity. It's really stable, it's very useful. There's lots of people using it to great effect. Microservices on the way up. Kubernetes, not quite there for me. The reason I think this is important is because if you go online and you read lots of blogs and lots of articles about, migrating to microservices or something, rewind 5 years ago and everyone was saying microservices is the answer to everything. If you search for should I do microservices now, you just get an absolute, probably the first few pages of Google filled with, you shouldn't do microservices, this is so hard, blah, 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 blah. That's right in the trough. And now we are coming out to a point, I think, where it's something that's actually feasible. And so I want to talk a little bit about how we might do that. So should you migrate? Like we at Fat Lama, we're not ready for Kubernetes. Personally, we have a solution that's working fine, simpler technologies. We're running in ECS on AWS. No one's ever run it in production. It won't add any business value in the short term, and it's still really difficult to do. That's changing, but for us, it still feel like it's a bit of a stretch. So no need for us to migrate, right? You don't always have to do it. We're running fine the way we are. We are moving to microservices, but I should say that microservices might not be, the answer for your team right now. Sometimes a monolith is much simpler. Even especially as if it's a smaller company and you're still figuring out what your product market fit is, you need to understand your problem domain microservices way more complex than needed. Something I learned very quickly from Uber is that if you're successful, everything's going to be rebuilt anyway. I don't think there's a single line of code that I wrote at Uber that's still there. It's probably for the best. This is just to say that don't worry too much about the choices you make. Don't worry too much about trying to be on the latest thing. If you're successful, the company will grow. What you just had one engineer working on before will then have 10 engineers being able to build a much better or more thorough solution for that problem. So I've not seen companies work efficiently at scale without microservices, personally, even the big enterprises, but I'm sure it can happen. So, not necessarily, I'm not some microservices zealot, but I think it's a good way to go. But things are instantly harder. I don't want to go through everything. There's plenty of articles online telling you about why this is hard, but there's plenty of problems that you're going to encounter when you do it, so just make sure that you're aware of some of the problems you're going to have. Okay, so with all that said, I'd like to talk a little bit about what it might be like to migrate to microservices, or maybe not straight to microservices, but start to break out your monolith into a more sort of usable structure for the different teams as you go cross-functional, become more agile. So hopefully what we're going to achieve is something like this. This is what we've done recently at Fat Lama. We've gone from having a web and a mobile client, talking directly to a monolith that straight everything in one database, a monolithic database, to putting in place this gateway layer and starting to break out services from the monolith and starting to break these services out from the monolith and using them independently and shrinking that monolith as we go. Okay. So step zero because I forgot it originally and then realized that this is absolutely the most important thing. You have to set up, you sort of build a foundation for success here, right? You've got to get your house in order before you even start. You need a working test suite. You're going to be doing lots of hairy changes in the code to refactor things. You don't have to have everything fully tested, but at least have a test suite that you can run on the existing code base before you even try rebuilding and building something new. I think it's important to have changes building in CI, and I'm sure lots of people talk about that this conference. A big one for me is observability. This is something that was basically the first major change that I made joining Fat Lama, was making sure that this observability stuff was in place. So if you can't build graphs like this with a few clicks, then you probably need to invest some time in observability. And I'll talk a little bit about ways you can do that. But really, it's very, very important that you can capture metrics about your system, capture metrics about how it's performing, so that when you come to do these refactorings and switches, you can see instantly, in real time, what changes are happening in the system and where the traffic is flowing and that kind of stuff. Along with that, obviously, logging, very important, and alerting, another important thing to have. Like, sure, if you have a graph that shows you something is broken, that's great, but if you don't get told without looking at the graph all the time, then you're going to miss stuff. So there's really great tools to do this, and people think it's probably harder than it is. When I joined Fat Lama, I think within a day of starting to get this observability stuff going, we had graphs like this. So you can find like Docker containers already built, which combine like InfluxDB, Telegraph, and Grafana, which is what we run. There's also like Prometheus and other things as well. But you can just find this Docker container. I just spun up an EC2 instance, which is why I think the last part of being able to run this stuff in the cloud is important. I just picked, EC2 instance, threw this Docker container, Docker Compose file on it, ran Docker Compose up, and it brought up this whole stack of this monitoring software. And at that point, you can just start to use clients that are already built off the shelf to send stats to this system. So yeah, it doesn't have like lots of redundancy, and if that server goes down, well, we don't have stats, but you know what, for the last 6 months, it's been fine. You don't have to like go through this huge project to add observability. You don't have to get all this buy-in from the business. You can just put it on a small server somewhere. It's going to cost you pennies, and you start to see the benefits immediately. Again, feature flags. Something that's really, really important, I think, is being able to, and I guess this is critical actually for what I'm going to talk about next, is being able to control where traffic flows in the system and who sees what. So we use feature flags for that. So that's you can basically go on a UI and hit a button and direct people through the code in different ways. So we use this for rolling out to users. We use it for testing internally first, and then we do a 10% rollout and 20%, etc. We use feature flags for all this stuff. So that's really important as well. So if we're going to break down our monolith, the first thing that I think is really important to do is to identify all your externalities, right? So we have this monolith with all these different modules in them, all talking to lots of different systems. For Fat Lama, this is stuff like sending emails, sending texts, Google for authentication. I'd class a database as an externality, logging, anything cached, writing to disk, whatever it is. You need to know what all of these things are. You need to group them together. Otherwise, when you start to pull out different parts of the system, you'll realize that you didn't cover everything. So we want to get to, we're still in a state where our monolith might be a bit messy. We have all these modules, but at least our externalities are covered. So we add these sort of new layer, and this is like an interface into this third party. And this is going to be really, really important for when we migrate, that we have everything internally going to one place, so that when we move, we can just redirect everything that goes to that one place to another system. And then the next step is to sort of look at the middle layer. So we have our externalities, we have our output covered. We want to look at the middle layer, and we want to start to isolate our business domains and entities. So for Fat Lama, users, items, transactions, reviews, messages, whatever it is, we want to still within that monolith just reorganize the code and restructure the code a little bit so that we bring all these things together. And the reason we do that, again, is so we have one place we can go to where we know this is everywhere where we deal with business logic for transactions or for messages, rather than having stuff all over the code base. Makes it very, very difficult to refactor. And the same thing for the input side. So we want to organize our inputs. So we have, we might have had web and mobile calling into all these different files that were in weird places around the system, and we want to basically put a very strong API layer in front of that. So we might define our users API or our transactions API, and have everything going to that one place again, so that we can decide to fork from that layer. So it's really the same thing over and over again here. It's just organizing things into interfaces so that you can swap out what's behind that interface in the future. So if you're familiar with object-oriented programming, this is the same thing, but on a bigger scale, right? On the architecture scale rather than on the specific class scale. It's just putting an interface somewhere so you can change the implementation behind it. And you might see here that some of the things that we found when we started to do this whole thing is that we have an input at the bottom that's not even being used anymore. We probably deleted 15, 20 endpoints just from reorganizing our code and realizing that stuff wasn't actually used. So there's some benefit in doing this as well. You'll find that lots of stuff is not used anymore as you go and clean up. So yeah, so far we're just reorganizing our monolith into these different layers. And this is a screenshot that's lifted straight from the internal docs that we made about how to design a service. But you effectively have those three layers. You have the input layer, you have the business logic layer, and you have the output layer, right? And the output for clients, externalities, and for databases. And this is a really important but long process. If you don't do this and you try and rebuild the system, you're going to be in a world of pain, because you're going to find that your business logic layer is tied to your input layer. Maybe it reads some HTTP headers, or maybe the service layer responds with some specific HTTP code. And when you go to build your new system that uses RPC instead of HTTP, you realize that there's no direct translation, and you have to rebuild a lot of the business logic. So if you can keep these things separate and clean, you're going to be in a much better place for swapping out any different part of the system. Yeah, and this is a long process. We've been doing this at Fat Lama for the last 6-8 months, and still delivering the business value as we go. So we're rebuilding parts of the system. We are adding new things to the monolith still, but as we go along, we're starting to gather things together in the place where they should live. And we're doing that iteratively so that we can keep adding value as we go. So, the fun part. How do we actually get the new system going? Now we've reorganized the old stuff, or we've at least reorganized part of the old stuff. The first thing that I don't see many people do, but something I learned at Uber was build a dummy service. So they call it Stooge at Uber, and there's actually 3 of them talking to each other in production when a team was sort of rebuilding or designing a new communication protocol. They set up these 3 servers that all talk to each other so they could see exactly how it's going to work. So this is something that we've just done at Fat Lama. It's very, very useful. It's just a service that does pretty much nothing, right? You can send it a message, it sends you the same message back. You can send it a message and it throws an error, and also like a delay. You can send it a message, it will wait a certain amount of time that you tell it and then respond okay. And this is it seems completely useless, but a very, very useful thing to do as you're figuring out what all your new technologies are going to be, what your new stack is going to be. So we are moving to a Go-based gRPC microservices deployment, and we built this service that basically did nothing, and we put it into production. And what that meant is that we could figure out our logging, our metrics, our alerting, our deployment process, our CI process, our communications. We discovered so many problems just by building this simple service. We realized that we didn't have a good plan for handling SSL for communication between services, which we just ended up just saying, let's not worry about that now, let's ditch it. And all of these things that we learned, if we try to do this whilst trying to build a project that had a big, important, critical business function and a tight deadline and timeline, we would have run into, we would have been over by weeks in terms of our delivery. So just building this thing, getting everything in order, getting your deployment pipelines, all this stuff in order with a simple service that doesn't really do anything is a really, really useful thing to do. And I would suggest if you're going on this crazy endeavor to do something similar, even if business people might look at you and think, why would you spend time building something that does nothing? It's very, very useful. Okay, so now we've built our Stooge, we put it in production, we figured out all of our stuff, we know how to do logging, we know how to do all this stuff. The next part is the fun bit where we get to pick our first candidate for Exorcism from our monolith. So obviously in this diagram it's this one because there's only 2 in the diagram. But pick something that doesn't have many complex dependencies, that's not necessarily critical to the business as a whole. One of the things that we picked at Fat Lama was our system to verify your email address and phone number. So when you sign up, you get an email, you click that, and it calls this service effectively, right? It's a very small, contained, simple thing. Yeah, that's what you want to start with. And you get to do the fun bit, which is rebuild that thing as another service. So take your new technologies, rebuild, and this is a little bit fork-ish, but you don't have to rebuild the whole thing. You can just rebuild the part that you're going to use first. So maybe your user's API is 30 functions long. You might just pick 3 or 4 of them, most critical ones, just create and delete or something like that, to rebuild first, and then you can go to put that into production. It's a really good chance to improve your API, so think hard about it. Don't just duplicate everything you have and just pull the code out, literally. The next thing you want to do is to start to duplicate write traffic to this new service. Okay, so we're building this new service, but the old one's still in production. What we want to avoid is that fork where we just switch everything over in one go. So what we start to do is, because we have this nice place where everything is going into one module with our interface that we've designed, we can start to say, okay, when this call comes into our user's service to create a user, we're just going to fork that call and also write it to the new system as well. And then what we have is a system where we have the old system completely working as it was before, nothing's changed, but also the new one, we're testing it out. And this is where we'd use feature flags to enable this. We'd first say, okay, for all employees, write to the new database, for all maybe 10% of users, and we slowly ramp it up. We don't go to 100% straight away, because then you at risk of causing other problems or breaking the new system as well. So we slowly ramp up this system until we're writing everything to both the old one and the new one. And then what we do is we make sure that they match. So we want to test the integrity of our data. We look at the database from the old system, we look at the new one. We might have to run a backfill on the new one. Now all of our writes are going, we can bring all the old data from the old one and run a script to backfill. So our new data should match in theory exactly. And maybe we run a script that just pulls data from the old one and data from the new one and compares it to make sure that the new system is behaving the same as the old one. And then we can start to reading from the new service. So before we were writing, now we've written to 100%, we've made sure our data is the same. We use the feature flags, again, to control reads from this new service. So we let the old one continue on, and we start to just pull a little bit of that traffic with a feature flag from the side and start to replace with the new data coming back. And that way, and I should say that you might need to sort of write some code to, maybe the new data isn't structured in necessarily the same way, or maybe it's a completely different database technology. But because we have this one interface point, we can manipulate that data on the way back in to make it match what the old API expects, right? So we start to switch this over. We do controlled rollout with the feature flags again, and we look at the monitoring. We check the graphs. How many requests are going to this new service? Is everything okay? Is it handling the load? We roll it out for our employees first, anyone with Fat Lama email address, and then to 10% of users, and so on, until we're confident that the new one is working as we expect. And then it's cleanup. So now we've moved this service out, and we have a slightly smaller monolith, which is great. And we have this new service, running in production, and at no point along the way did we ever just say, turn the old one off, turn the new one on. Everything was a slow, controlled rollout. And really, that's the way that you can do this without breaking stuff. If you're doing this for the first time, I will say it's very, very important to go through these steps and get it right. Because if you say, we're going to move to microservices, hey, business, this is going to take a little bit of time, but trust us, this is the right thing to do, and you do it wrong the first time, that's not going to go well when you say, actually, we want to do this again with 5 other services. People are going to say, you know what, let's not bother, everything's fine in the monolith, let's keep it as it is. So really go through the effort of making sure that you do this right the first time if you are going to go along this path. And a final thing is just a quick note on the clients. I did say at the start, we've moved to this model of having the gateway calling these other services. Obviously, the only thing I've shown you is taking a service, some logic out of a monolith and breaking it out separately. One of the things that we've done at Fat Lama, which is very, very useful, is to put this gateway layer in place. And what that does is it protects your clients, especially mobile, where you can't roll back if you push a change, from all of this change that happens in the back end, right? So we don't want anything to affect the users, and we don't want to break people's old mobile apps. So we put this gateway layer in place that lets us start to call through to these new services without interrupting the clients. The first thing we did to set this up was actually just have a gateway that's just a proxy, and everything passes through that directly to the old monolith as it used to. And the apps and the clients don't even know that it exists. It's just a proxy, and then we start to take little pieces, little certain endpoints that the clients hit, and forward those to the new services instead. So again, it's another interface layer that we're putting in place, and that is going to really help you if you're doing this for front end, not just back end as well. I think that's pretty much everything I have. Thank you very much for listening. I'm happy to take any questions.